Thank you so much for joining this lesson. Today we shall be discussing the Maseno School Mathematics paper 2025. So I hope you shall follow through and you shall get something in today's discussion. So we'll be discussing paper 2, section 1. Remember to subscribe, remember to share so that you may invite a friend to this live broadcast. Our consultation line remains 0704 153366. So please reach out to us for more questions and for any consultations. Remember our holiday program, which we are bringing to you over the August holiday. You are invited to register through my number 0704 153366. There is a very serious lineup of facilitators in sciences, in mathematics, and in the languages. So kindly reach out for a very rich program, which is going to help the candidates, the Form 3 students, and the Form 2 students. So you are highly invited. Make an attempt of registering with us. Welcome to the paper now. Number 1, a carpenter has 3-meter long wood cut into 7 equal pieces. He approximates each piece has 42.8 centimeters to the nearest millimeter. Calculate the percentage error in the approximation. So for us to get percentage error in the approximation, remember this is not a percentage error in the computation of anything. It's just an estimation. So we should get the error itself. We should get the error first, so that when we take the error out of the actual dimension, then we will be able to get the percentage error by multiplying that by 100. So what is the error? We take 300 centimeters, which is the total length of the hood. Then we divide this by 7. So we can have it as a fraction actually. So 42 and 6/7. This is the actual after dividing 300 centimeters. Remember, 3 meters equals to 300 centimeters. That is the interpretation I want you to have as we start. Then, now this length is going to be divided into 7 equal pieces. After dividing by 7, I'm getting each piece shall exactly be this one. So when we subtract the estimated, which is 42.8, this one can also be written as 42 and 4/5. That way, we will get the error itself. So I'm now taking, when I take the difference, I'm getting it in a fraction, in a decimal, 0.05714 centimeters. That's enough for significant figures. So the error is the difference between actual value and the approximated value. That is the simplest definition of an error. The difference between actual value and approximated value. And we have already seen the difference. So that is the error. So for us to get percentage error, now we need to take the error, we divide it by actual value. Then this one we multiply by 100 for us to get percentage error. So when I multiply that, I'm getting the percentage error from the calculator is 0.13333 is carrying actually percent. So that is the percentage error in the approximation which was done by this carpenter. So that's how you're supposed to work out the problem number 1. Now at number 2, without using a calculator, evaluate 3 plus 2 the root of 4 minus 3 minus 2 the root of 2, also raised to power 4. So with this now, you shall allow me to advise you that this is on binomial expansions, and we're going to first, under the first expression, we raise it to power 4. Then we also address the second expression, we also raise it to power 4. Then now we'll be doing the difference. So let me start by telling you that the binomial coefficients of power 4 should first be listed. And they are listed as 1, 4, 6, 4, 1. So now these are the binomial coefficients of power 4. So now we start by expanding the first expression. 3 takes power 4, while 2, the root of 2, takes power 0. Now in the second term, 3 shall take power 3 as 2 to the root of 2 ascends to power 1, like that. In the next term, 3 descends to power 2, but 2 multiplied by the root of 2, this one ascends to power 2, 3 power 1, then 2, the square root of 2 raised to power 3. And finally, as 3 takes power 0, 2, the root of 2, this one shall now be power 4, like that. So that's how we expand binomially. Now this is equal to, let me check the first term. We'll be having 3 power 4, which is equivalent to 81. So this is 81. Then the next term, plus. Remember, anything power 0 is 1. Therefore, I'm multiplying 1 times 81 times, again, 1. Now, I'm starting with 4 times 27, because 3 power 3 is 27. This one I should multiply by 2, giving us 216. And root 2 plus, let's check the third term. We're supposed to be very careful at that point now, because when we talk about this is a 6, then 3 power 2 is 9. Now, I want us to agree that when we multiply or we raise 2 to power 2, that becomes a 4. And again, the root of 2, when squared, we shall get 2. Yeah, root of 2 squared shall become 2. That way. So it's 6 multiplied by 9, multiplied by 4, then multiplied by 2, because the root of 2, 6 times 9 times 4 times 2, root 2 squared is 2. This is 432. Plus the fourth term now, we start with 4 times 3 power 1, remaining 3. So 3 power 1 is 3. We are having 2 power 3, giving us 8. Then the root of 2 power 3, let me show you what it is. The root of 2 times the root of 2 times the root of 2. That is what it means by power 3. So this becomes 2 on its own. So it shall be 2. Then we remain with the root of 2. So from this part alone, we shall get 2 the root of 2. That's what I want you now to understand. 2 the root of 2. Now with that 2 the root of 2, we get back now to our multiplication. We start by 4. 4 should be multiplied by 3. 3 should be multiplied by 8. Then 8 is being multiplied by 2. This one gives us 192, the root of 2, that way. And finally, the fifth term, this one shall be having a 1 times 1, because 3 power 0 is 1. Then 2 power 4 is 16. Then when we have the root of 2 power 4, this is what we will get. The root of 2 times the root of 2 times the root of 2 times the root of 2 again. So this becomes 2, and this one becomes 2, such that we are getting 4 from that point. So now when I multiply, I'll be having 1 times 1 again times 16 times 4, 64. So that is the first binomial expression after being expanded to the power of 4. The second one shall be, actually, we'll be dividing now. The second one we'll be subtracting, sorry. The second one shall be, the second one is 3 minus 2, the root of 2, power 4. Now, it shall be having the same terms as the ones we are having from the first expansion, only that in the second one now, negatives shall be alternating with positives. In this case, it shall be 81 minus 216, the root of 2, plus 432 minus 192, the root of 2, plus 64. Yeah, negatives alternate with positives. So that's how it shall be. So now we can combine now. We need 81 plus 216. This is the first expansion. 432, 192, the root of 2, plus 64, then minus 81 minus 216, the root of 2, plus 3, that is 432, sorry, we write it well. 432 plus, after that plus we have a minus, 192, the root of 2, plus 64. So when the negative at this point takes effect, it shall be 81 plus 216, the root of 2, plus 432, plus 192, the root of 2, plus 64, minus 81. Then this now becomes a plus 216, the root of 2, minus 432, plus 192, the root of 2, then minus 64. That is how the signs shall be changing. I want you to understand that this is a very involving paper and it needs a lot of attention. So please make sure that you are following carefully. Okay, terms now, 81 and 81 shall cancel because that's a minus. Then 216 root 2 plus 216 root 2. 216 plus 216, that becomes 432. So that becomes 432 root 2. That one, they just combine like that. Then we have 432 minus 432. That one cancels. Then when we talk about 192, the root of 2, and another 192, the root of 2, that can also be combined. 192 plus 192, that becomes 384. So we'll be adding 384, the root of 2, and you discover that they are again like terms. Then 64 minus 64, that one cancels. So now from here, we shall have 432 plus 384, giving us 816. The root of 2. So that is the final answer. Remember, we've not used a calculator anywhere. We have not used the mathematical table. So that is how we are supposed to work it out. Now looking at number 3, find the number of terms of the geometrical series 1 over 16 plus 1 over 8 plus 1 over 4. The series continues that are needed to make a sum of 2 power 16 minus 1 over 16. So we are already given the sum and we are given part of the geometric series. From this series, it has already been defined that it is a geometric series. That is to tell us that there is a first term, which is 1 over 16, and there is a common ratio that multiplies one term for us to get the successive term. So what multiplies 1 over 16 to give us 1 over 8? The same factor should also multiply 1 over 8 to give us a quarter. And the same factor should multiply a quarter to give us the successive terms, and so on. So 1 over 16 multiplied by a certain ratio should give us 1 over 8. And now we can remain with R by taking 1 over 8 times 16. This is 2. So this 2 is the common ratio. It can also be confirmed by saying that 1 over 8, if multiplied by 2, is it giving a quarter? Yes, it's giving a quarter. Therefore, the factor multiplying here is 2, and that becomes our common ratio. So we have a geometric progression, a GP here, whose first term is 1 over 16 and a common ratio of 2. This means now we can say that from the formula that sum of a given number of terms is usually given by A into, when we take the value of R, then we raise to N minus 1, then this is divided by R minus 1 that way. So that's how we get the sum of a given number of terms in a geometric progression. So the sum is already provided, so we need the number of terms now. 2 and 1 over 16 minus 2 raised to power 16 minus 1 over 16 is given by first term 1 over 16 into R is 2 raised to a known N minus 1. Then this is divided by 2 minus 1. Yeah. So what are we having now? 2 raised to 16 minus 1 over 16. This is equivalent to 1 over 16 into, because when we divide by 2 minus 1, which is 1, it shall remain the same. Let's continue solving the same equation to see whether we will get the value of N. I can open these brackets so that I have 2 raised to 16 minus 1 over 16. This is equal to 1 over 16 can multiply here. And you will discover that we are having 2 power n over 16 minus 1 over 16. And if you are very careful now, you shall discover that 1 over 16 can combine because it is on both sides. So 2 over 16 equals to 2 power n out of 16 because this one and this one are the same. So they shall cancel out and become a 0 that way. So at this point now, we are needed to find the value of n. Allow me multiply by 16 and also by 16 on this side, such that 2 power n equals 2 power 16, and also 16 can be written as 2 power 4. Yeah, that way, 2 power 4. So 2 power n equals to 2 power 20. And if that is so, because the bases are the same, then n is going to be 20. It's a very interesting question. I don't know whether we are flowing together, but the question is really good. Actually, I'm doing it for the first time here. This is a question that I've not seen before. But looking at how it has been set, I really like the approach. It's a very good question. I like the setup of this particular problem. So you're supposed to group terms like that. You just flow. As long as you know the formula, as long as you can interpret, interpreting a geometric sequence, a geometric progression for that matter, into first term and r, then substituting well and playing along now with that equation. You play along with that equation until you find the value of n. So you can follow through again. You can just rewind the video. You can watch again and again. Yeah, you can watch again and again. Let's get to number 4 now. We are told that a point, P prime, which is -4, -6, is the image of P under a transformation R followed by T. Given that the transformation T is 2, -1, and 1, 0, that is the matrix representing transformation T, then the matrix representing transformation R is 3, 0, 0, -2. Find the coordinates of P. Okay, this is one of the questions that can be approached using different ways, very different ways. So we can first say this, that there is this final image. Is that final image? And remember, a matrix multiplying object gives us image. So transformation R followed by T. That means the last transformation that gave us the coordinate that we are having is T. So we can say that T, which is 2, -1, 1, 0, multiplied a certain the first image, that is, for us to get -4, -6. So I think we can relate this to get our immediate image that gave us the final image that we are having. So when we multiply the rows and the column here, that is 2 by x and -1 by y, we get -4. And when we multiply the second row and the same image, that is x by 1 and 0 by y, should give us -6. So we are already having x as -6. That means y can be obtained because this is the second equation which has directly given us the value of x. So y can be obtained by saying 2x is -6 minus y equals to -4. So -12 minus y equals to -4. Y can be positive here. And then we shall have -12 plus 4 being -8. So there is a certain coordinate of P, or the first image of P. I don't know whether we are getting this now. There is the coordinate of P. There is the first, I don't know why they have said this. They could have actually given us let me just modify the question to have this one as P prime. So that we say, now P prime is having the coordinate -6, -8. This is the image which was now transformed finally by T to give us what had been provided. Then now we should say that there is the original P, which is not known now, which was initially multiplied by R because we started by R. So R, 3, 0, 0, -2, multiplied the original P, which is also not known, for us to get the first P prime that we have computed. That way. So I'm coming from the final image to say that the transformation just before this final image was done by matrix T. So this matrix T multiplied a certain image to give us the final image. So this first image has been calculated as P prime, like that. So now, what was the original P now? So we can get back to the first transformation that was performed. That is transformation R. This is going to be 3 by x and 0 times y to give us -6. And again, 0 by x and -2 by y to give us -8. So from this, I'm getting x as -2. And I'm also getting from the second one, the value of y as +4. That means the original P was -2, -2, 4. That is the original P, -2, 4. That way. I expect now people to reason in such dimensions. Just be a thinker and you will find yourself managing such questions. Let's look at number 5. Find the possible values of C for which the equation x power 2 plus cx plus 2c plus 5 equals to 0 as repeated roots. Repeated roots means that when we expand our left-hand side, we shall get the same factors, meaning that the left-hand side is a perfect square. In other words, the expression just before the equal sign equals to 0, the quadratic expression is a perfect square. This is a perfect square. Now, if this is a perfect square, then there is how the terms in a perfect square are related. And they are related in such that b over 2 squared should give us AC. This can also be expressed as b over 4 equals to AC, which can further be described as b squared equals to 4AC. So this is how the terms in a perfect square are related. The value of b squared equals to 4 multiplied by AC. So according to the expression above now, then we can talk about the value of b is C. C squared equals to 4 multiplied by A, and at A, we have only 1. Then times C. At C, we are having 2C plus 5. So C squared equals to 4. When you multiply by 4, the bracket shall open to give us 8C plus 20. Possible values of C. This means the values of C can be several. So it's a quadratic equation now, and we can solve to get the values of C. So C squared minus 8C equals to 20. So we can add a constant to both sides, so that I'm using it's a quadratic equation whereby I'm solving using what we call the completing square method. So it's good we review one of the methods on solving quadratic equations. So we need to take the value to make it a perfect square, the value of b over 2 squared. So negative 8 over 2, then squared. That becomes negative 4. We square to get 16. So we also add 16 at this point. We're going to have this one. It's now a perfect square. So to factorize it, we need c. The sign that follows is a minus. The square root of 16 is 4 squared equals to 36. At this point, we can take square root on both sides so that we have c minus 4 being equal to plus or minus 6. Plus or minus 6. Yeah, plus or minus 6 to plus or minus 6. So the value of c equals to 6 plus 4, which is 10, or the value of c equals to negative 6 plus 4, which is negative 2. So the possible values of c is either 10 or c is equal to 2. It's a negative 2, sorry. So we have the two possible values of t. A very good question again, but a bit engaging. You know, you're used to solving for the unknown terms in a perfect square in a very easy way, but looking at this paper, it needs a student who is having the content, the right content for that case, and a student who knows what they're doing. Remember to comment, remember to subscribe, remember to share, invite a friend kindly to our programs. Let us know where you're watching us from. You can leave a comment kindly. Let's know where you are watching us from. At number 6 now. Solve the equation 2, the cosine squared of x plus the sine of x equals to 1. Then the range is going to be negative 180 all the way to 180 positive. So let's now check how this trigonometric equation is going to be solved. Moving from quadratic equations to trigonometric equations now. We're going to apply some trigonometric identities. We know that the cosine squared of an angle plus the sine squared of the same angle usually gives 1. And if this is so, then the cosine squared of an angle can be given as 1 minus sine squared of the angle. Applying this identity now in the equation that we have, it means 2, and instead of the cosine of x squared, 1 minus the sine squared of x plus the sine of x equals to 1. 2 minus 2 sine squared of x plus the sine of x equals to 1. So now we can actually group some terms here by saying negative 2 the sine squared of x plus the sine of x equals to negative 1, like that. I think we can rearrange this equation because it is taking some quadratic shape. We can have everything taken to the right, so that we start with 2 sine squared of x minus the sine of x. There is already a negative 1 here, and this side we are now remaining with a 0, like that. We can let the sine of x to be a certain unknown, say even t, so that we say 0 equals to 2t squared minus t minus 1. This is the quadratic equation that we are solving. The quadratic equation that we are solving. So let's solve it even using a different method now, factorization method. And applying the factorization method means I need product AC, so 2 by -1, giving us -2. Then sum the value at B, which is -1. So now this is going to be -2 and 1. Their product is -2, their sum is positive, -1. So we can now re-express the equation by starting with, let me use the space up here. We start with 2t squared. Then -t can now be replaced by -2t and +1t, which is just t. Then -1. This is equal to 0. From the first two, I can factor out 2t to remain with t minus 1. Then plus 1 t minus 1 in the brackets that way. So I'm having t minus 1, 2t plus 1 equals to 0. When you look at this, then you shall realize that we have two values of t. T minus 1 equals to 0, implying that the value of t is 1. And for sines, we cannot use that value. So we will talk about 2t plus 1 being 0, implying that the value of 2t equals to -1 and t equals to -half. T equals to -half. Therefore, the sine of x, which was the value of t, equals to -half. When it is -half, ladies and gentlemen, we have to ask ourselves a few questions. And these few questions are, when we are having -half, what is the quadrant according to the unit circle? Let me sketch it. According to the unit circle here, we know that in the first quadrant, all trigonometric ratios are positive. In the second, sines. In the third, tangents only. And finally, cosines only. So we need an acute angle measured in the quadrants where sines are negative. An acute angle measured in the quadrants where sines are negative. So we shall talk about an acute angle, which will be given by the sine inverse of half. And this acute angle shall be sine inverse of half is 30. So we need an angle of 30 degrees. An angle of 30 degrees measured in the quadrants where sines are negative. And where are sines negative? Sines are negative in the third and in the fourth. So measuring the angle in the fourth, remember an angle in the fourth is given by 360 minus theta. An angle in the third is given by 180 plus theta. An angle in the second is given by 180 minus theta. Then in the first quadrant, it is the theta itself. So we need the angle in the third and in the fourth. So in the third, it shall be, we talk about 360 minus 30, giving us 330. Or x can be according to the third quadrant, 180 plus 30. This is going to be 210 degrees. So these are two possible values of angles. The two possible values of angles which satisfy the equation above. Number 7. The position vectors of P and Q are OP negative I plus 2j plus 3k and OQ 3i minus 2j plus k respectively. A point R divides PQ externally in the ratio 2:1. Calculate the distance of R from the origin correct to 1 decimal place. This means the first thing to be calculated here is the coordinates or the position of R. Then from there, with the position, we can find the magnitude, which is the distance from the origin. So the first thing we are finding, let me analyze the division first, which is an external division of a line using what we call the ratio theorem. So we have our line here, whereby there is a coordinate P. And by the way, the coordinates of P can be extracted as -1, 2, 3. Then we have another coordinate here that we are calling Q. And Q is 3, -2, 1. Then we are having R now, which is dividing externally. And we don't know the coordinates of R, X, Y, Z. We don't know the coordinates of R. So let me interpret the ratio first. R divides PQ externally in the ratio 2:1. So from P to where R is, there are 2 units. The ratio 2:1 means from P to where R, that is the divider, is, we have 2 units. Then for us to move from R to Q, we are moving 1 unit backwards. That is the meaning of external division. So it means there is 1 unit here and there is 1 unit here. In other words, if it was Q to divide PR, then it would do so in the ratio 1:1. In other words, it is the mid. Q is the mid. Q is the mid of PR, in other words. And actually, we can use now the knowledge on midpoints to find the coordinates of R. So for us to get the coordinate at the middle point, which is 3 on the X, 3 is usually given by -1 plus a known X over 2, because it should be X1 plus X2 divided by 2 for us to get the X at the middle. So this is 6, -1 plus X. To remain with X here, then we shall have this one being 7, because we are taking -1 to the left, like that. Then we are having 2. We are having -2, the middle value of Y. How do we get the mid value of Y? The first Y plus the second Y out of 2. This is -4 equals to 2 plus Y. So do we remain with Y here? Then we have to take -4 and we subtract 2. Then for the Z, we shall talk about the middle value of Z is 1. This is given by 3 plus the known Z divided by 2. This shall be 2 equals to 3 plus Z. So to remain with Z, then 2 minus 3, which is a -1. In other words, the position of R equals to 7i minus 6j minus Z, like that. Minus Z. So with this knowledge now, we can proceed to talk about the magnitude of R. Magnitude of R, which is a vector, shall be 7 squared minus 6 also squared minus 1 also squared. Then we take square root. So this should be plus and plus. So 7 squared plus 6 squared plus 1 squared, which is just 1. So the magnitude is the root of 86. So the root of 86 now, you know, we've been told to one decimal place. So it shall be 9.3. 9.3 units. Yeah, 9.3 units. So that is how you are supposed to approach that question. It's a very simple question, actually, but it needs a lot of thinking. You see, I didn't proceed to the ratio theorem. There are very many questions involving external division of lines, whereby we apply the ratio theorem. This is just a coincidence that Q becomes a midpoint. So solving it becomes very easy according to the vector 1 form to work. Look at this. Let me emphasize something on the external division in the ratio 2:1. So when we are told the word externally 2:1, then it means from P, we are moving 2 units, then backwards 1 unit. So that at the end of the day will leave us with 1, 1. Assume you are told that, and by the way, this ratio, the whole of this statement can be replaced by ratio 2:1 without the word externally. When that negative appears, it means it is an external division. Assume you had been told ratio 5:2, or externally in the ratio 5:2. It means from P to where R is, we are moving 5 units, then backwards for 2 units. At the end of the day, if Q is here, then we'll be having 2 and the 3 remains here. So that's how I want you to get used to the splitting of the ratios, more so when it is negative or when it is an external division. When you get to shifting grades online school, then you just search external division of a line, shifting grades online school, or ratio theorem, shifting grades online school. You shall see a variety of videos whereby I have emphasized the application of the ratio theorem in the calculation of unknown coordinates using the division of lines. Number 8 now. The cash price of a TV set is 70,000 Kenya shillings. Mweni bought the set on hire purchase terms by paying 12 equal monthly installments of 7,000 each. With the first installment treated as deposit, calculate the monthly rate of compound interest charged on the balance, correct to 2 decimal places. Something that we're supposed to understand is that when items are bought on hire purchase terms, the balance is usually treated as the principal, then the total installments that will be paid are treated as the amount paid. In other words, interest is charged on the balance. Interest is usually charged on the balance after the first deposit, and this balance is from the cash price. Therefore, when Mweni came to the shop to purchase a TV set costing 70,000 shillings, she came with 7,000 at hand. So this first installment shall be treated as the deposit. So it was costing 70,000. And now she's making a down payment of 70. See? So now we shall talk about 70,000 minus 7,000, giving us 63,000. So the actual balance that remained is 63,000. Now, interest shall be charged on this. Interest shall be charged on this particular amount. I'm trying to check on my screen. Just a little bit. Let's now talk about after paying this deposit. Now look at this. They were 12 installments. So the installments now, which will give us the remaining balance, the balance paid. In other words, the amount paid at the end of the period shall be the other installments now are what will become installments by 7,000 each. Is this 77,000? Yeah, 7,000 for 11 installments now. 77,000. So the point here is Mweni would have paid a balance of 6,300, but she's ending up paying 77,000. So there is some interest being charged here. The interest is compounded. Therefore, we would say amount is usually given by principal into 1 plus the rate of interest, which is a percentage raised to n. Yeah, raised to n. The interest is per month, so n is the number of months. So the amount Moeni is ending up paying is 77,000. Principal is the balance which she would have paid, 63,000. Then we have 1 plus r over 100 raised to 11 months. So we can first divide 77,000 by 63,000. This is giving us 1.2222. 2 is recurring, in other words. 1 plus r over 100, everything raised to power 11. So because everything is now to power 11, then we can take root 11 both sides. We take root 11. So 11 shift power of 1.222. This is giving us 1.01841 equals to 1 plus r over 100. How can we remain with r over 100 here? By subtracting 1 to the left. Yeah. So r over 100 equals to 0.01841. How can we remain with r itself now? We can now multiply by 100. So that we have 1.841. Let me check the accuracy demanded. 2 decimal places. If we need the answer in 2 decimal places, then the value of r shall be 1.84%. 1.84%. Yeah, 1.84%. That is it. So that is how we get the rate. It's a very interesting question, but learners should understand that learners are supposed to understand that the balance after deposit is made is usually treated as the principal. Then the total installments that the customer will end up paying will be treated as the amount. Then from there, the rate of interest can be computed. Number 9. Find the equation of the tangent to the circle. Find the equation of the tangent to the circle x. X squared plus y squared minus 4x minus 6y plus 3 equals to 0 at point 54. We're supposed to reason so much here. And the first thing that we're supposed to conclude is, according to a tangent, remember, a tangent cuts, okay, it touches a circle without cutting it. But we know that in case we draw a line from the center of the circle and we draw it to the tangent, this line shall be perpendicular to the tangent. So we are going to use the knowledge of the tangent and the radius, knowing that they are perpendicular to one another, for us to get the equation that we need. Let me give a simple illustration of what we are talking about. Check here, ladies and gentlemen. With a circle like this, and this is a center, radius and tangent. This one is tangent. Radius and tangent are usually perpendicular, right? So using the point 5, 4, and the center that we shall calculate, we will be able to get the gradient of the radius. And with the gradient of the radius, because it is perpendicular to the tangent, we shall be in a position now to find the gradient of the tangent itself. Then from there, we proceed to get the equation. All right? So let's proceed. Look at this. The equation has been provided. So we're going to ensure that we get the center. X squared minus 4x, that is the x components. We shall be adding a constant here to make it a perfect square. Then we shall talk about plus y squared minus 6y. Then there is a 3 here equals to 0, but we can add a constant first there, equals to 3 becomes negative here. Then we shall be adding the two constants for the y component and for the x component to make it a perfect square. Remember, our main interest is even the center, not even the radius. So for us to get the first constant here, we need negative 4 over 2 squared. That becomes 4. And we add 4 here. Then for the y, we need negative 6 over 2. We also square it. That becomes 9. So we add 9 to this point. So with this, we can factorize the x part. This one, x minus 2 squared plus y minus 3 squared. This is equal to negative 3 plus 4 plus 9, giving us 10. So we're supposed to know that the center of this circle is 2, 3. If the center of the circle has been determined as 2, 3, then we can get the gradient of radius. So gradient of radius can be gradient 1 actually. The radius is passing through 2, 3, which is the center, and also 5, 4. So we need 4 minus 3 out of 5 minus 2, according to y and the other y, then 5 and 2 as the x. This is going to be 1 over 3 if the first gradient is a third, that is the gradient of the radius, then it means that gradient of the tangent, which is gradient 2, shall be -3. It is becoming -3 because the radius and the tangent are perpendicular to one another, and the product of their gradients should give us -1. The product of their gradients should give us -1. If it should give us -1, then a third can only be multiplied by -3 to give us -1. So now with that knowledge, we can use -3 equals to, now for the tangent, change in y means y minus 4 divided by change in x, x minus 5. So now we can cross multiply to get the equation. Y minus 4 equals to -3x and positive 15. To remain with y, we shall have -3x plus 19. -3x plus 19. So this is the equation of the tangent. Equation of the tangent at all. Again, it is my hope that people have understood the interpretation which I have applied at that point. A very good paper, a very standard paper. Remember our consultation line is 0704153366. So that's our consultation line. You can kindly use it. At number 10, simplify the root of 3 out of 1 minus sine 60 plus 3 divided by 1 plus the cosine of 30. Am I supposed to first conclude something here? Because we are going to apply surds and trigonometry, surds and trigonometry, yeah, for special angles. But according to trigonometry 1, for two complementary angles, sine of one equals to the cosine of the other. Therefore, the sine of 60 is the same as the cosine of 30. The sine of 60 is the same as the cosine of 30. So we shall not struggle at that point. If we take this equilateral triangle, 2 units, 2, 2, 2, then this is 60, 60, 60. If this is perpendicularly bisected, we shall have a length of 1 unit and 1 unit here. And the angle here becomes 30. After that, we can derive some trigonometric ratios here. For example, if we need to work out what we are calling the sine of 30, not the sine of 30, sorry. We need the sine of 60, not the sine of 30. And for us to get the sine of 60, we should get the opposite length. So with 1 and 2, it means we need 2 squared giving us 4, 1 squared giving us 1. So the square root of 3 will be the height there. So the sine of 60 equals to opposite length. Opposite length should be divided by hypotenuse. Opposite out of hypotenuse. The same means that a cosine of 30 shall be opposite, adjacent, sorry, root 3 over hypotenuse. So that's why I was saying sine 60 equals to cosine of 30. So now we apply the same in our expression here. The root of 3 out of 1 minus root 3 over 2, then plus 3 out of 1 plus root 3 over 2. root 3 over 2. With this now, we can proceed now to work out our surd now. It's now a surd statement, a surd expression. So let's work it out. 1 minus, that is now the LCM. With this, we can divide the LCM by the first denominator. So the LCM divided by the first denominator, we shall remain with 1 plus root of 3 over 2. So when we multiply by the numerator there, there's a 3 here. The LCM again divided by the second denominator, we shall have 1 minus the root of 3 over 2. That. This now from the numerator, let me expand. Root 3 plus root 3 times root 3 over 2. You know root 3 times root 3 becomes 3 itself. Plus, this is again 3 minus 3 over 2, the root of 3, that way. That's now after expanding the numerator. After expanding the numerator, yeah? So this is now being divided by, this is being divided by, look at this. The denominator, which is the LCM of the denominators that we had, is what we call a surd and its conjugate. And to simply expand this, we need 1 squared, which is 1, minus the root of 3 over 2, also squared. Let me show you what this one will give us. This is going to be 3 over 4, 3/4. Discover that we are getting a quarter now at the denominator. So at the denominator, let me use quarter is already established there. It's 1 minus 3/4. Then now I have to group some terms on the numerator. 3 over 2 plus 3. You know 3 over 2 is 1.5 plus 3. That becomes 4.5. 4.5. Then when we are having a root 3 minus root 3 minus 3 over 2 root 3. You know 3 over 2 is 1.5. That is 1.5. So it's like we are having 1 minus 1.5. This should give us half. Yeah, this should give us half, which is negative. So negative half the root of 3. Or rather root 3 over 2. Root 3 over 2. So now we cannot remain with a fraction at the denominator. So we can multiply everything by 4. Actually, let me have it this way. 9 over 2 instead of 4.5. 9 over 2 minus root 3 over 2. We are multiplying, we are dividing by a quarter, which means everything can be multiplied by 4. Dividing by a quarter means multiplying by 4. So this can simplify too. When 9 over 2 is multiplied by 4, it shall become 18. I hope we are together there. It shall become 18. Then root 3 over 2 by 4. It shall become 2 and the root of 3. So unless there is a specific order to give our answer, this can further be factorized. But now this so say correct, because the format to give the answer has not been dictated. So this is already correct, but it can further be factorized that way. So that's how we work out such an expression. A very good question again. A very good question again. Number 11. Given that u plus v equals to m, and that 1 over u plus 1 over v equals to 1 over f, express m in terms of u and f only. Well, this one, you're supposed to understand that actually those who take physics from both of one, that is thin lenses, they'll be able to understand that this is what we call the mirror formula or the lens formula. So it is a combination of the lens formula, which is in physics, and also the concept in Form 3, making subject of a formula or changing the subject of a formula. Yeah, so let's check at these. Let's check at this. I'm going to work out the left-hand side in this way. The LCM on the left-hand side, is going to be U multiplied by V. Okay? So U multiplied by V is the LCM. When I divide LCM by U, I'm getting V. Plus LCM divided by V, I'm getting U. That way. This is equal to 1 over F. Yeah, 1 over F. So if that is 1 over F, then we can multiply something here. If we multiply through by UV, it shall be U plus V equals to UV out of F. And remember, the value of UV has been expressed as M. It has been expressed as M. So the value of M equals to UV out of F. Yeah, UV out of F. So that is how you are supposed to express it. Number 12. Letters and packages can take up to 2 days to be delivered by Wells Fargo couriers. The following table shows the percentage of items delivered at certain times after sending. So when you send a parcel, a package, or a letter, if it can arrive at the same day, both letter and package, 40, 15% respectively. After 1 day, 50, 55 respectively. After 2 days, 10, 30 respectively. So in this one now, this is simply what we call a probability space. So what has been provided here is probability space. And from this space, we are trying to find the probability that when a letter and a package are posted together, the letter arrives at least a day before the package. So a letter arriving before the package means it can be the letter arriving before the package means letter same day and package after 1 day. Package after 1 day. We just want to check the combinations where after the two have been sent, the letter shall arrive before the package, or It can be the letter arriving one day, after 1 day, while the package takes 2 days. While the package takes 2 days. A letter arriving at least 1 day before the package. 1 day before the package. So the combination that will give us a letter arriving 1 day before the package, 1 day before the package should be letter arriving the same day, but package taking a day, or letter arriving after 1 day, but the package taking 2 days. Or it can be the letter arriving the same day, but the package takes 2 days. Actually, they are these combinations now. The letter arriving the same day, but the package taking 2 days. Letter arriving the same day and package taking 1 day. Letter arriving after 1 day, but the package takes 2 days. So from the first, the probability shall be the letter arriving the same day is 40%, and package taking a day is 55%. The second option, letter taking 1 day, 50%, while package taking 2 days, 30%. And finally, the letter arriving the same day, but the package letter arriving the same day is 40%. But the package arriving after 2 days, which is 30%. That way. So let's get all these possibilities. 40 by 55. So the first is 11 over 50. The second is 3 over 20. And the last one, 3 over 25. Therefore, it should either be 11 over 50 or 3 over 20 or 3 over 25, which means addition. 11 over 50 plus 3 over 20 plus 3 over 25. This gives us, let me add up, 11 over 50, 3 over 20, 3 over 25. This gives us 49 over 100. This can also be written as 49%. It is an expression of probability. It can also be written as 0.49. So that's the probability. I hope the probability space has been properly analyzed. Letter arriving at least a day before the package. At least a day before the package. So it can be after 1 day, or earlier by a day, or more than a day. 13. A very good question in number 13. A trader mixed sugar grade A costing 150 per kg with sugar grade B costing 120 per kg in the ratio 5:1 in order to make blend X. In what ratio should grade B sugar be mixed with blend sugar, blend X sugar to make a blend Y costing 135 per kg. Let's first talk about the first mixing here, whereby we are mixing a ratio of 5:1 A and B. So 150 shillings, 5 such kilograms with 120 per kg with 1 kilogram, and these are 6 mixed kilograms. So what is the cost of a mixture of a kilogram after mixing A and B? 150 by 5 plus 120 divided by 6. I'm getting 145. This one is X. So blend X, which is arrived at by mixing grade A and B in the ratio of 5:1, is costing 145. If it is costing 145, now we are supposed to mix the blend X together with blend B again to come up with Y. And Y should cost 135. So blend X costing 145. If we choose 6 X kilograms, then we also mix this one with the kilogram costing 120 of B, and we choose Y of them. Then we should be able to divide this by the number of kilograms involved for us to get 135. So with this, we can talk of 145x plus 120y equals to 135x and 135y. Grouping terms, 145 and 135x gives us 10x. Then 135 and 120 gives us 15y. To remain with x, we divide by 10 to get 15 over 10y. Now, to do away with y on the right, and that we remain with 15 over 10, we should divide by y. So if x over y equals to 15 over 10, then the ratio x is to y is 15:10, which can be simplified by 5 to give us 3:2. So the ratio in which blend X and B were mixed to give us Y, which is costing 135, is 3:2. 3:2. That is 3 equals to 2. From this point, allow me now to say that there is an alternative that we can use to approach the last option here, this question here, whereby we can say X is costing 145, B is costing 120. We want to mix them to get Y costing 135. So we can just get the differences. 145 minus 135, this gives us 10. 135 minus 120, this gives us 15. So the ratio in which the blend X and the grade B are mixed is going to be 15:10, and we can't leave a ratio unsimplified by 5:3 by 5:2. So the final step can also be done alternatively using that approach. Number 14 is a question from statistics, and it's a very good question. This one is a very good question. So we can look at it. The deviations from the mean of shoe sizes for 10 students are -3, -2, -6, 0, 1, 1, 2, 0, D, and 3. Given that the mean shoe size is 43, determine the interquartile range. The first thing that we are going to find is the value of D. And we are supposed to know that the summation of all deviations from the mean usually gives 0. So -3 plus a -2 plus a -6 plus a 0 plus 1 plus 1 again plus 2 plus 0 plus D plus 3 should give us 0. All deviations from mean must give 0. All deviations from mean must give 0. So let's add up all deviations now. -3, -2, -6, then 0, then 1, then 1, then 2. And we are having again a 0 and a 3. So I'm getting -4 plus D equals to 0, meaning that the value of D equals to 4. So now we have all the deviations. This one is a 4. So that in case we add up all the deviations, we shall get 0. This -5, -11. Yeah, I think it's okay. It's okay. It's okay. So the value of D is 4. After getting that, now we are supposed to get the interquartile range for shoe sizes. The shoe sizes are X, and we should know that deviation is usually given by every value minus the mean. How is each value varying from the mean? How is each value varying from the mean? So with the deviations provided, then we can get the shoe sizes themselves, because we need to get the shoe size X by taking each deviation plus the mean. Yeah, deviations are given by each value minus mean. That means for us to get the values whose mean was calculated, then we need to get deviation plus the mean. So we need to get all values of X. That is now the shoe sizes. The first deviation is -3 plus a mean of 43. So a mean of 43, yeah? A mean of 43. Therefore, the first shoe size is 40. -3 plus 43, we get 41. -6 plus 43, 37. 0 plus 43, 43. 1 plus 43, 44. Another one, 44. Then 45. Then 43 because of 0. Then 47 because of 4. Remember, D is 4. And finally, 46. And finally, 46. So we are having all the values now. We are having all the values. So with this, we need to get interquartile range. Remember, interquartile range will be given by Q3 minus Q1. Just that. Q3 minus Q1. So the first thing that we're supposed to do here is to arrange the shoe sizes in what we call ascending order. The least shoe size is 37, comma. Do we have 38, 39? No, so we go to 40. After 40, there is 41. After 41, we don't have 42, but there is 43. After 43, there is another 43, yeah. Then after 43s, there is two 44s. Two 44s. Then there is a 45. And finally, there is shoe number 46. Shoe number 46. So let me check whether that arrangement is right. Just want to check whether I've accommodated everything. Remember, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 deviations, meaning that we should be having 10 shoe sizes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. What about from here? There is 47, sorry. I'd left out 47. Shoe number 47 is also there. So they are now enough. With this, let's talk about the median first. The median is the value that is lying on the middle part. So when you remove one here, you remove one here from the lower side, from the upper side, the lower side, the upper side, the lower side, the upper side, and you shall discover that two values are lying at the middle. So median shall be a value here. The first thing to get median. The first thing is to get median. So the median shall be a value between 43 and 44, which is 43.5. 43.5 that way. So the median is the value at the middle. Now, what we are understanding here is that the median divides the data into two sets. So we have to calculate now what we call the lower quartile. The lower quartile is the median of the lower set of data. After median has been obtained, we can see the lower set of the data. So this lower set of the data, now we need its own median. So we can cancel this one, then this. You discover that at the middle, we are remaining with 41. Therefore, 41 is our Q1. The lower quartile is 41. Then we need to get the Q3, which is also called the upper quartile. Upper quartile is the median of the upper set of data when median has been obtained. So the actual median is 43.5. That one has been obtained. But now this has given an upper set of the data. So the median for this upper set now should be our upper quartile. Like that, we discover that it is 45. So for us to get interquartile range, we need Q3 minus Q1. 45 minus 41. This is going to give us 4. So the interquartile range is 4. The interquartile range is 4 that way. Number 15 as we wind up. Number 15 as we wind up. This is from logarithms. Question from logarithms. So let's solve it. We are solving for x in the equation. The logarithm of x to base 4 minus the logarithm of 2x to base 8 equals to a half. We can see that the bases are not the same. So we can work out, can do some efforts to make sure that the bases are splitted. Allow me work by letting first the logarithm of x to base 4 be something like t. And with this, we can say that the statement can be changed from logarithm to index notation, such that this can become 4 power t, yeah, 4 power t is equal to x. So I have changed the statement from logarithm to index. And further, looking at the left-hand side of this equation, It can be 2 power 2t equals to x. 2 power 2t equals to x. So the question now can change to, again, logarithms. Back to logarithms now, such that we have the log 2 base 2 of x equals to 2t. I'm changing this index notation to logarithm form. At that point, how can we remain with t? How can we remain with t at this point? It can only be so by dividing through by 2. When you divide through by 2, then the left hand side shall be half the log of x to base 2. So t has been changed. After changing t, let us also work with the log. We let the log of 2x to base 8 be something like y. And from this, we can say that 8 power y equals to 2x. And if this is so, then we can further express and say 2 power 3y instead of 8. 2 power 3y equals to 2x. With this, we can rewrite back to logs, whereby the logarithm to base 2 of 2x equals to 3y. So how do we remain with y? By dividing through by 3. So this shall be a third the log to base 2 of 2x. So now that y and t have been expressed now as logarithms to the same base, we can rewrite our original equation. Instead of log x to base 4, log of x to base 4, we had let it to be t. So we write this. So it shall be half the logarithm to base 2 of x minus, instead of log of 2x to base 8, we now replace it with this. So minus a third the log to base 2 of 2x. This is equals to half. Yeah, that one is equal to half. At this point now, we can remind ourselves of some logarithm laws, like the law that talks about n, the log of a is the same as log of a power n. Log of a power n. So this way, we can say that the logarithm to base 2 of x power half, x becomes power half now, minus the log to base 2, 2x now becomes power a third, equals to half. Yeah, a third becomes power. That becomes a power. That way. Charge my pen, and I hope you are really following. At that point, we can again apply the second law of logarithms. We are still on logarithms. Remember, when there is a minus at such a point, we usually apply this law that say, if we have the log of a minus the log of b, this can be simplified by taking the log a over b that way. So with that knowledge now, we can proceed because there is a minus there. And so we will be talking about the logs to base 2 of x power half divided by 2x power a third. This is equal to half. From this point, allow me convert again the statement from logarithm form to index notation. From logarithm form to index notation. And changing this from log form to index notation means I can take 2 power half, because 2 is the base, and half is the answer on the other side. So 2 power half equals to x power half divided by, this one is being divided by 2 power a third, and also x power a third, that way. So at this stage now, we can start looking for how we will solve for the value of x. In case we apply some laws of indices, we can multiply by 2 power a third both sides. So that 2 power half is being multiplied by 2 power a third. And this shall be x power half being divided by x power a third. So at such a stage now, we know that the powers on the left should be added. So it becomes 2 power 5 over 6. And this is equal to, on the other side, x, the powers should be subtracted, and we shall get 1 over 6. So x power a sixth is the same as 2 power 5 over 6. So power a sixth means root 6, which is being taken on both sides. And so that can cancel, and we shall have 2 power 5 being equivalent to x. See, now the value of x can be concluded to be 32. So the value of x is equivalent to 32. A very good logarithm equation. Kindly follow through once again. You can rewind the video so that you may see what we are doing. You can just rewind it and it shall be well. Remember, later we'll be doing the section 2 of this good paper. It's a very well thought out paper which requires a student to have some good understanding. Number 16, which is our last question in the section 1. The graph below shows the relationship between two variables, t and h. So we have the graph already drawn, t and h. Calculate the instantaneous rate of change at B. So at point B, hope we can see point B. Instantaneous change means obtaining the gradient at that particular point, and it is the gradient of the tangent. So we draw a tangent through B, so that along that tangent, we can find gradient. So with this now, we can pick any two coordinates along this tangent, and any two coordinates can be 1, 5, and also we can have another one as a, let me check another coordinate at B itself. This is a, no, this is 3. So 2.8 and 3. Yeah, 2.8 and 3. So with this, we can get the gradient to give us the rate of change. So 3 minus 5 out of 2.8 minus 1. So this is going to be negative 2 out of 1.8. So the rate of change is going to be, negative 2 divided by 1.8. This is going to be 1. Okay, negative 1 and 1 over 9. So that is the rate of change at that point. Then look at part B now. Average rate of change between A and C. So between A and C, those who cannot see the graph very well, it's good for you to know that there is a point C, which has been indicated here, and there is a point A, which has been indicated there. So let us look at the relationship at that point. So looking at that, you see that at C, the value of T within C and A, the value of T is changing from 6.4 then at C, we are having 1. So from 1 to 6.4, from 1 to 6.4, that is according to A and C. Or we can simply pick the coordinates. At A, we have 6.4, and the H value is 0.8. Then at C, we are having 1 and 7.4. 1 and 7.4. 1 and 7.4. So with this now, we can say that the rate of change is going to be 7.4 minus 0.8. This one is being divided by 1 minus 6.4. So this is going to be, when we take 7.4 minus 0.8, this is 6.6 out of 1.0 minus 6.4, giving us negative 5.4. Therefore, 6.6 divided by that value shall be negative 1 and 2 over 9. In other words, we have found the gradient for A and B. So we have T changing from 6.4 all the way to 1 as H changes from 0.8 all the way to 7.4. So one is increasing as the other one decreases. So later, ladies and gentlemen, we'll be meeting to discuss a very wonderful section 2 here. And as we continue preparing for that, I would request people to support our programs so that we may continue coming live to you for the presentations. Any amount will go a long way. So if you're supporting our programs, please use the till number attached, 497772. God bless you. See you next time.